Okay, the first part about a problem like this is defining the dimensions and figuring out how things really are. Now, the 30 inches here goes all the way to the back. So what that means is I could take this piece here by itself, or I could just say this 2 inches is part of the 30, so I'm just going to take this and this all together. It's going to be 30 by 40. Does that make sense? Yep. So 30 by 40 is 1,200 square inches. So that covers the top surfaces. Now on the front, I have this piece and this piece. Now the 4 inches goes from here up. And 2 inches, so I can do 4 by 40 and 2 by 40 separately. But I'm going to take 4 and 2 makes 6 by 40. Does that make sense? I've got those two rectangles put together. So that's another 240 square inches. The side's just a touch more difficult. That's why I use 2 inches here to make it a little bit easier on myself right now. This is 2 by 30. And this is 2 by 4. So that gives us, what, 1,508 square inches. Correct? No? Oh, I forgot the other side. You're right. Good catch. On the other end over here, I got the same amount. Another 60 and another 8, right? So that gives us 1,576. That better? Square inches? How did you came up with that much? 1,576. I did too. You had 1,508? All right, well. You can't be too bad off. You screwed up the same way the teacher did. So we got 1,576. Problem is this is $2.80 per square foot, not per square inch. How do we get from square inches into square feet? 144. You got it. Because that's just the formal way of doing a unit conversion. So 1750 or 1576 divided by 144. 10.94 square feet. Now times the $2.80 per square foot. So $30.64. Questions? Do you want it back for a while? I have no problem giving them back to you for a while. You okay? Oh, yeah. Well, okay. So you can see it's just a matter of taking it piece by piece. The part that most people mess up, by the way, is usually the converting. A lot of people would come up with an answer of 360 some here dollars. Yeah, you divided by 12 instead of 144. Yeah. You got to remember, square feet and square inches are different than feet and inches. That is a big issue. Did you do that on your quiz too? You can have your quiz back. I'll give your quiz back before I grade it so you can change it. Anybody else needs their quiz back, just let me know when we hit a break. Okay, well, we are going to today, if I can get to it, look at something specific to CNC and machining. We're going to start out talking about calipers. Of course, this is a caliper. Right now, what this is measuring isn't such a big deal, but there are several parts to the calipers. You got the jaws right here. Then you've got the blade of the caliper, the scale of the caliper, which is like a big ruler. This little thing right here, the little thumb screw, is for adjusting it so you can slowly move it in and out. You can grab onto it and just slide it in or out. They're made to do that. But that's so you can slowly push it in and out. And it's also made, partly made to slip so that you can't over tighten it. So when you go to clamp it down on something, that allows you to tighten it just the right amount. And when you read a caliper, this is a dial caliper is what we're going to concentrate on. I kind of took the vernier calipers out of the curriculum because you just don't use vernier a whole lot anymore. I realize a lot of you use digital. Unless you spend like $400 for a digital caliper, they're not very accurate. The cheap ones, the $40 or $50 ones, are not very accurate at all. Digital is very, very sensitive to temperature, which means you need to calibrate the thing literally every half hour or so in order for it to be accurate. And the problem with digital is, you know, most calipers you calibrate them by zeroing them out. If they're away, I think most of them are calibrated or designed to work at like 71 degrees. Is what most 71 or 72 degrees, or most of them are set at. If you venture away from that temperature in either direction, they're off. And the further you are away from where they're calibrated, they're off. So since you calibrate them at 0, the bigger the item is that you're measuring, the further off it is. So what you really need to do is need to calibrate them. If you're measuring something that's 4.5 inches, you need to calibrate it at like 4 inches or something, so it's closer to it. And there's a way to do that. I don't know, you guys seen gauge blocks at all yet? Okay. You can do a 4-inch gauge block, and you can actually put a 4-inch gauge block in the jaws and hit the Terry button to zero it out. And so now whatever measurement you get off of the thing, you just have to add 4 inches to it. If you have a good one, they will allow you to zero them out wherever you want to. So anyway, that's where we're going to start out. This is an inch caliper. You can see along the blade here, you've got big numbers there. Here, I'm going to blow this up a little bit. You've got big numbers like that right there is the whole inches. That would be 3 whole inches. These little numbers are the tenths. So that's 3.1, 3.2, 3.3, 3.4 on up. We read the caliper, or we read the main scale of the caliper off the jaw, depending on the style of caliper. Some of them read right at the edge of the jaw here. This one does not. This one has this extra little bump here that sticks out. If you're not totally sure when you're looking at your caliper, if you're not totally sure where to read the main scale, close the jaws and see what lines up with 0. And then, of course, you got the dial, which just adds to it. And you do have to make sure you look at the dial. This one says 0.001 inches. So whatever we read on the dial is 1/1000th of an inch. So right here it'd be 99 thousandths, or close to 1/10 of an inch. So let's look at reading some. There we are. Okay, so there's our caliper. I'll make the color here so I can see it. This one, you can see the jaw goes straight through, so we're going to read it at that edge. That's the edge we're going to read the main scale at. So how many whole inches do we have here? 2 whole inches, tenths, 5. So far we're at 2.5. This reads 15. It is 0.01, so the last digit of that has to be in the thousandths place. So that is 2.515 inches. This one, 5 whole inches, 0.621. Perfect. This one, 3.6 and then 66. How about this one? This is 4 point. Now I see the 9 there, but how do we know whether we we're either just before the 9 or just after the 9. Yeah, we look right here. If the dial was at 0, we'd be right on the 9. We're not quite to 0 yet, so that means we're just before the 9. So this is 4.887. This one, 0.271. This one, 4.443. And this one, okay, 1.1, so 1.142 inches. Now we're changing the style a bit, but it really reads the same. You can see the jaw reads here instead of up at the front edge. This is going to be 563. This one, 0.814. Good. This one, 1.046. Good. This one, 1.261. And this one? Okay, yeah, we're right at that 6. And we see the dial is just past 0, so that tells us we just passed the 6. 1.609 inches. This one. 1.896. You can see we're right at the edge of the 9, but we're not quite to the 0, which means we haven't quite made it to the next mark yet. So it's not quite 9. I know that one can be a little tough to read from the back of the room, can't it? This one, 2.137 inches. This one's the same one. No extra charge for the second one. How about this one? 2.486. Good. This one. 2.836. And then perfect. And this one? 3.653. Perfect. This one changes a bit. Where did my micrometers go? Oh, there it is. That was weird. We'll get a blown up picture of this whole thing. This one is designed to measure not to the nearest 1,000th of an inch, but to the 64th of an inch. This is actually designed for cabinet makers. Mastercraft up here used to go to 64th of an inch. They used to use something similar to this. They now have gone to where they're manufacturing to 100th of an inch rather than a 64th. Makes it easier. But on here, you can see they still have the whole inches marked out. And these marks in between, this is what? This is the halfway. 1, 2, 3, 4, 5, 6, 7, 8. It's marked to the nearest 16th here. But it's also the 16ths are marked out on here. And then the 64ths, of course, are in between. So like this here, right now it's at 1 whole inch. This is the 1/8 would be how many 64ths? 8 64ths, so 9, 10, 11. So between 10 and 11, I'd say it's slightly closer to 11 64ths. So, back to the show. This is the one we just did. How about this one? How many whole inches? 0. 1/2 is how many 64ths? 32, so 33, 34. It's between 34 and 35. Which do you think it's closer to? 34? Picky. That don't help a whole lot.
No.
I'd say maybe 35. I don't know. That one's really close to just dead center. We'll call it 35 64ths. Now, every year I have someone tell me, well, why don't we just, if it's right in the middle, why don't we call it 69 1/28? Because our measuring device does not measure to the nearest 1/28. It only measures to the nearest 64th. So it would be implying something about our measuring device that we really can't see. I know that sounds silly because to me this one looks like it is dead in the middle, which would be 69 1/28. But we're not supposed to say that. We're not supposed to do that. Exactly. Exactly. Yeah. So this is 1, and we've got 5/16 here. Remember, 16 would be times 4, so that's 20 64ths there. 21, 22. Of course, I'm not going to leave it as 22 64ths. I'll change it to 11/32. So 1 and 11/32 of an inch. How about this one? 7/8. How about this one? 2 and... I'd probably do the 5/8, which is going to be how many?
40.
Perfect. 40 64ths. So this is 39, right? I only did a few of those because the 64th inch calipers are kind of a pain. But I just wanted to expose you to them so that you know they're out there. They do exist. Yeah, they're not my favorite. No. Yeah. Well, it's just there's too much in between. There really isn't anything on the main scale outside of the whole inch, which makes it inconvenient. Here is metric caliper. Now our main scale here, there's one thing that's very confusing about a metric caliper. The numbers on the main scale here are centimeters. That's 1 centimeter, 2 centimeters, 3 centimeters, and so on. But you look at the dial here, this is labeled 0.01, not millimeters, but centimeters. Or not centimeters, but millimeters. How? Well, what it is, this is a 1/10 of a millimeter. This is 1/100th of a millimeter. That's a 1/10 of a millimeter. So we can't use centimeters on the main scale and millimeters on the dial. We don't mix dual units like that in the metric system. So what we have to do is we have to read this as 10 millimeters. And we have to read this, even though it's 2 centimeters, we have to read it as 20 millimeters, and so on. So this is 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, and so on. Now here we've just passed the 3, so we've just passed the 30 millimeter mark. Now on here we're at 31, so that's 30.31 millimeters. Here we have how many? 21, 2, 3.96. Here we have 52.41 millimeters. Not really, no good reason that I have found. They just don't do it. Probably because it's just so easy to convert between centimeters and millimeters, they figure they don't need to specify. To me, it is confusing. I think it's.
I just see it as if it's cheap to print it.
That's basically it. They don't want to waste the ink to put zeros on it, pretty much, and do the engraving.
Have you seen one with like tiny zeros behind the two?
No, I haven't. I've seen inch ones where they've got, you know, the big 2, then the 1, 2, 3, where this is a 2, 0 like that.
Yeah.
I've seen that on the inch ones, but never on the metrics. Yeah, because to me it's confusing because I used to, before I got used to these, I used to always want to call this 1.7. Because on the metric, the big number was in front of the decimal point, and then the smaller numbers were the tenths. So going from the standard, the inch caliper to the metric caliper, I wanted to do the same thing. So, but this isn't 1.7, it is 17.77. So it's just the fact that it's inconsistent from the inch to the millimeter.
Glad it's not in my cubits or some crap.
47 hands.
Oh.
Micro hands.
That's a 4 hand. 1.7 hands.
Well, micro is actually a millionth.
Million?
Yeah, so that'd be a really tiny horse. That'd be a seahorse. So anyway, this is 0.9. Well, 9, right? Remember, this is the 10 here, so that's actually at 9.12. How about this one? 62.48. Very good. This one. 67.47. And this one? And this one? 46. Do I need the 0 on the end of that? Say yes.
Yes.
Why do I need the 0 on the end of it? Because it really is 50 hundredths. It's not 5 tenths, it is 50 hundredths. There's a difference. Remember, it's that implied error. This is plus or minus 5 thousandths of a millimeter. If I left the 0 off, it'd be plus or minus 5 hundredths of a millimeter. Very, very different. How about here? 2.2. Oops, not 2.2. 22.37. And here? 28. We've just passed 0, so we are past the 8. 28. Very good. 28. And this one? 27.60. Good stuff? Okay, good. Well then, I have a packet to hand out to you. That will do right now.